The Leuku knife was the traditional knife of the Sami people of Northern Europe. This knife was used for many tasks, including shelter building, skinning game, gutting fish, and food preparation. Most examples that I saw when researching this knife were around 12 inches in total length, with around a 7-inch blade and a 5-inch handle. And that varied, give or take, a few inches. But the example I'm going to be making here has a 7-inch blade and a 5-inch handle. I've cut this out of an old saw blade. And in order to make sure that this steel is good quality steel for knife making, I'm doing a test here, quenching a test piece in water and seeing if it's hard enough to skate a file, which it was, and seeing if it got hard enough to be brittle and break, which it did. Taking a mild steel plate and grinding it, you can see that the sparks are much more intense, and they burst at the end, indicating that this is a high carbon steel. So I feel confident in making a knife out of this steel. The Leuku knife is usually a through tang construction with a stick tang that goes through the handle and is peened over on the end. Before grinding my bevels in this knife, I stamp my maker's mark. This is a wooden jig I made to get consistent bevels when I make my knives, and this is the bevel setter that I use for making Scandi ground knives, which is just an edge that goes straight to the edge of your knife without a secondary bevel. I clamp my blade up in between two pieces of angle iron, and with the platen of my grinder tilted, I get the correct bevel angle. Grinding these bevels is a fairly simple process. I just go back and forth on each side until I meet in the middle. And by switching back and forth from side to side, I ensure that I don't go too far as I approach the center line of the blade. Before doing my heat treatment of the blade, I preheat the oil with a large piece of steel. This is just a big chunk of rebar that I have. I'm aiming for 120 degrees Fahrenheit. After checking with a thermometer, I see that I need to raise the temperature a little more, so I use another piece of steel to do that. And right there I'm at 121 degrees Fahrenheit, which is just about as close as I can get. So I heat the blade in the forge, and once it becomes non-magnetic, I quench it in the warmed oil. This will make this steel extremely hard, but it will also be brittle. And to check that it was hardened properly, I use a file, and if the file skates over the edge and doesn't bite in, I know it was hardened properly. I temper the blade by putting it in an oven and holding it at 400 degrees Fahrenheit for a number of hours, and I do that for a few cycles. And what that does is it softens the steel somewhat and toughens it, making it less brittle. After the blade comes out of the temper, I put it back in the grinding jig and use a fine grit belt to clean up the bevels. So now it's time to start thinking about the handle. And before I do anything, I want to protect the blade. So I wrap it in a shop towel and some masking tape, and that protects my hands from getting cut and also protects the blade from getting scuffed up. So I'm cutting some micarta here and some pieces of yellow vulcanized fiber liner, and I'm planning on doing a stacked handle construction here. The Dremel makes quick work of milling out a slot, and I use a carbide burr to do that. Needle files help refine the slot until it fits the tang of the knife. This is granadillo wood. It's a really dense wood and it's very oily, which should make it stable. It's really hard to drill into. The drill bit gets clogged easily and it smokes and tends to overheat the drill bits. Using a longer drill bit helps me get all the way through, but it produces a lot of smoke and heat. I overheated the wood and it cracked, so unfortunately I'll have to start over. So with a new piece of wood all drilled out, I use a hot piece of steel to finalize the shape of the slot. The steel heats quickly in the forge, and I use tongs to push it through that slot until I get it all the way through. This produces a lot of smoke and a lot of heat. Eventually I burn it through until it fits the tang of the knife. Before I do any glue up of the handle, it's important to scuff the surface on the tang of the knife so the epoxy has something to grip onto. Using the belt grinder, I grind these grooves down the tang of the knife, which provides more surface area for the epoxy to grip onto and should really help keep that handle on there permanently. I always make sure to clean everything with acetone before I do a glue up. And I try to do a test fit on everything just to make sure that it's all going to go together without any issues. Acetone is great for cleaning up any excess epoxy. I let this sit overnight so that the epoxy would be fully cured before I do any shaping on the handle. With the epoxy set up, I can peen over the end of the tang, and this will provide a really secure hold, and this handle should never come loose. quickly square everything up on my belt grinder before taking it over to the bandsaw and removing as much of the material as I can. And then it's just a matter of shaping the handle on the belt grinder. I like to use the slack portion of the belt on this grinder, and it really helps to round over these edges. Don't be like this guy, not wearing a respirator or any eye protection. Most examples of a Leuku knife that I saw had a flare on the end of the handle, and I'm just using the top wheel on my grinder to grind in this flare. And from here on out, it's just a lot of hand sanding to get the handle down to the desired finish. Once all the deep gouges are removed from the belt grinder, I use some Danish oil to finish off the handle. And I forgot how runny this stuff is. I'm used to boiled linseed oil, which is a little thicker. After putting that oil on, I think the handle looks really nice. It brings out the darkness of that black micarta, and the yellow liners really pop. Slicing right through that paper. And hair shaving sharp. So let's see how good she is at fire prep.